This is example 1 on 2.4, modeling with quadratic functions. So in this example, the graph shows a parabolic path of a performer who was shot out of a cannon, where y is a height in feet and x is a horizontal distance traveled in feet. Write an equation of the parabola. Then the performer lands in a net 90 feet from the cannon. What is the height of the net? So we're looking at two things. We want to know the equation of the parabola, and then the other piece is we want to know what is the height of the net. So we're given a couple of pieces of information in our parabola here. We are given the vertex as well as the y-intercept or a point. So let's write that. The vertex is 50, 35, and the point that we have is 0, 15. So our goal is we want to write an equation, and we're given a vertex and a point. What we want to use is vertex form. So vertex form is y equals a times x minus h squared plus k. By looking at the information we have, we know that the vertex represents our h and k. The point represents x and y. So we need to substitute that into the vertex equation. And then we need to try to solve for a. We have to solve for a. So I like plugging in our vertex first. So y equals a times x minus 50 squared plus 35. So that is our h and k here. We'll come back to that because that'll help us write our general equation later. Now we want to plug in x and y. So we have 15 equals a times 0 minus 50 squared, 50 squared plus 35. So to start solving this, we'll go ahead and subtract 35 from both sides. So now we're left with negative 20 equals a times negative 50 squared. So square both sides, we get negative 20 equals 2500 a. Then divide both sides by 2500, and so a will equal negative 1 over 125 or negative 0.008. So our equation is y equals negative 0.008, and I'll plug it into this equation here, this one. So y equals negative 0.008. Let me make this a little smaller so it'll all fit. So let me write a equals negative 0.008 here. And then if we write the equation, we have y equals negative 0.008 times x minus 50 squared plus 35. So that is our equation of this parabola. Now we need to find out the height of the net, and we're given that the performer lands 90 feet from the cannon. So 90 feet from the cannon is the horizontal distance, so therefore 90 equals x. So y equals negative 0.008 times 90 minus 50 squared plus 35. And when you solve for this, that gives you your y value, which is the height of the net. And so when you plug it into your calculator, you will get approximately 22 or about 22.2 feet. So try out the next example. It's tied to the human cannonball. So it says if the vertex of the parabola is 50, 37.5, we're still taking a look at the point 0, 15. That's the same starting point. And then we're also looking at that the net is 90 feet from the cannon. So try this out. And then in the next video, I will go over that question as well. And then also try out this one, number 2. Write an equation of the parabola that passes through the point -1, 2, and has a vertex of 4, -9. This is the example that you can expect to see on the test.